Okay, here we are at part 2 of the end of chapter 10 practice problems. So we are now on number 58, problem number 58, and part A tells us that we have 15.5 grams of silicon dioxide. Okay, now as I said, I think on the previous video, for each of these problems we're going to need to know the molar mass. So let me take a little side trip here back to the mole map. So you guys all have the mole map, right? And we are starting here at the mass station in problem 58, right? Because when you look at the all the problems, we're being given different masses, different numbers of grams of each of those substances. So we're clearly starting out here, and the problem is asking us how many moles is each of the following. So we're trying to get here to the mole station, okay? And clearly we're going in this direction, right, from left to right. And so the train, so to speak, that we need to catch is the 1 mole over molar mass train. So in each one of these problems, we're going to take the mass that's given to us and we're going to multiply it by a conversion factor, which is going to have 1 mole on the top and then the molar mass of that substance on the bottom. And that makes sense, right? Because if you're given a mass in grams, you need to cancel the grams out if you want to end up with moles. Okay, so this is just kind of the a visual reference to kind of get us ready for where we're going. Okay, well, let's see here. Where's my? There we go. All right, so number 58. Sorry, I'm just adjusting the screen here. Okay, so again, we're being told in this case that we have 15.5 grams. So job number 1 is we got to figure out the molar mass for silicon dioxide. And when we do that, what we find is that it's 1 mole is going to have a mass of 60.1 grams, and that's grams per mole. Okay, so as we saw in the last video, this is really the proper unit for molar mass. Okay, okay. So then to set up the problem, what we do is, well, what I like to do is, write down the thing that we're trying to solve in this step, just to keep that in our minds, and say the number of moles equals, and then we put in the value that we're given. Okay, so 15.5 grams, and we're going to multiply that by our conversion factor, which, as we said, is 1 mole over the molar mass, which is 60.1 grams. Okay. Now, as you can see, when we go to cancel units, we can cancel the grams, and that leaves us with moles, so everything's good. And if you just kind of use common sense, if 1 mole of silicon dioxide is 60.1 grams, then if you only have 15.5 grams of the stuff, you clearly are going to have less than 1 mole. And you're just based on your number intuition, I think you can see that 15.5 is about 1/4, about 25% of this. So I would expect our answer is going to be somewhere around 0.25 moles. And when you, in fact, do the calculation, you take 15.5, divide by 60.1, lo and behold, the answer is 0.258. And that's moles of silicon dioxide. All right, so I'm going to put a box around the final answer. Now, a couple things, finer points. Notice that I'm not just writing the answer as 0.258 and putting a box around that, right? This number, in the context of chemistry, or most of science, would be meaningless. Numbers can't just, most of the time they are indicating some quantity of something. So you have to have both. You have to have a unit for sure, okay, because that tells us whether we have 0.258 grams or 0.258 kilograms or milliseconds. And in chemistry, we typically have some sort of substance. So we need to indicate clearly how much we have of what sort of substance. Okay, now that's fine point number one. Fine point number two is that we are keeping three significant figures. So notice, in the beginning, in the problem it's given to us, we're being given three significant figures. This is from a measurement, or that's what we assume. And so the precision of the measurement device allowed them to record their mass to three significant figures. Therefore, when we take that measured value and put it through a set of calculations, our final answer can have no more precision than the instrument that was used to measure the substance. So we can only keep three significant figures here. So we need to be mindful of that as we go through these problems. Okay, good. So I'm not going to say nearly that much on the rest of these. I just wanted to kind of go over some of the more important things on the first problem. Okay, let's go to B. Oh, and by the way, just another thing as we go. Please, I really highly recommend that you attempt each of these problems before you watch the solution. Okay, so don't just sort of sit there passively and write down what I'm writing down. For this to work, you really need to attempt the problem yourself and then come back and view the solution just to check yourself. Okay, so B, we are given 0.0688 grams of silver chloride. All right, and when we look up the molar mass, or when we calculate the molar mass of silver chloride, we get 143.4 grams per mole. Okay, so that's the molar mass. Now, to convert this from moles to grams, we write down what we know, 0.0688 grams. And now we apply the conversion factor. So since we're going from grams to moles, we're going to need to put moles on top, the molar mass on the bottom, 143.4 grams. Grams cancels, and the answer, well, so here, again, if we stand back, you're taking a very small mass and dividing it by a pretty big number. So you should expect the answer to be a very small number, right? So, and when you do that, in fact, you end up with 4.80 times 10 to the minus 4, which is a small number, and the units are moles of silver chloride. Put a box around that. And there we go. Okay, so that's part B. Now, I'm going to go a little faster. I'm just going to give you the molar masses and the solutions, basically, to the rest. All right, C, you're given 79.3 grams of molecular chlorine. That's chlorine gas. The molar mass is 71.0 grams per mole. Okay. And when you work this out, you should get the number of moles equals 1.12 moles of chlorine gas. Again, notice I'm given three significant figures in the mass, and so I can only keep three in the answer. D. It says 5.96 grams of potassium hydroxide. The molar mass of potassium hydroxide that I got was 56.1 grams per mole. Okay, and when you divide 5.96 grams by 56.1, I think you can see you'll probably get something, around a tenth, a little more than a tenth of a mole. Let's see what we get. The answer is 0.106 moles of potassium hydroxide. There we go. E. We have 937 grams of calcium acetate. Okay, so this is maybe a little bit unfamiliar, this anion. Okay, so just to review this guy, if you look it up in your polyatomic ion table, this is acetate. All right, and just for a little extra, if you kind of write out the formula a little bit more fully, this is the structure of the acetate anion, and when it has a hydrogen here, so here in the formula the anion has 3, but if you cap it, if you add a proton, then you get what's called acetic acid. That is acetic acid. And this is the stuff in vinegar. So vinegar is nothing more than just a solution where you have acetic acid in water. It's like 5% solution, and that's what vinegar is. Okay, so the anion, you can attach that to many other things, like calcium ions. The molar mass, so this is going to take a little bit of doing, but that's going to be 4 carbons plus 6 hydrogens plus 4 oxygens, and the molar mass that I get is 158.1 grams per mole. Okay, and so then we take 937 grams of this stuff, divide it by 158.1, the final answer is 5.93 moles of calcium acetate. And that's our final answer. Okay, moving on. F. So we're given 0.800 grams of calcium, just elemental pure calcium. Okay, so when you look up the atomic mass of calcium and round it to the nearest 10th place, that is 40.1 grams per mole. Sorry, I kind of botched sorry about my writing. So if you have 0.8 of a gram, you're going to divide that by 40.1 grams, and I think you can see now we're going to get a pretty small number again, and when you do that out, you're going to get 2.00 times 10 to the minus second mole of calcium. Okay, there you are. Okay, now let's I think what I'll do is I'll stop here, and in the third part of the video we'll go through problems in number 59.